Welcome back to the Cloudcast. I'm your host, Brian Gracely, and today we're going to, continue to dive into aspects of AI that we're finding more and more people are interested, they're curious about, but really we're trying to make sure that we're diving into areas in which, instead of some of the hype and some of the things that are just sort of chasing, what's big in a model or what's the latest stock price or something, really want to dive into some things that are going to be very tangible to a lot of different people, a lot of different businesses, and are very, very usable today and have very applicable sort of ROI, business value, customer success types of things right away. And so very, very excited today to dive into one of those and really kind of dive into, what can we do when we start to integrate voice and voice understanding and text to speech and all those things. So very excited to have Scott Stephenson, who is CEO of Deepgram, joining us today. Scott, welcome to the show. Great to have you on.
Thanks for having me.
I want to dive into Deepgram and voice AI and all those sort of things. But before we do, give us a little bit of your background, because your background is pretty interesting, especially a lot of the sort of academic and research work you did prior to sort of starting Deepgram.
Yeah, I was Deepgram is the first tech company I've worked at, first and only.
Yeah.
But before that, I was a particle physicist. I built deep underground dark matter detectors. So I was part of a team, about a 15-person team. It was a pretty small team. It grew a little bit over time to maybe
Hmm.
around 30 people, but that worked on a really fast-moving deep underground dark matter detectors that was basically built in like a James Bond villain lair in like rural Western China, 2 miles underground, where they're constructing the world's tallest hydroelectric dam. And the experiment that we were building was this: you essentially hide underground to try to get away from any background radiation that is raining down from the sky or that is produced by just everyday objects. And you're trying to make the quietest place in the universe from a radioactivity perspective, and we succeeded in that. But the reason for doing that is because if you see anything else, if it's quiet and nothing is happening, but you see something else, then it's probably dark matter. That
Yeah.
was the premise behind the experiment. But it was really interesting, that type of experiment. We had to do signal processing on waves. We had to Deepgram does, like what we work on now is cutting edge audio AI.
Right.
And looking back at that time, it's actually really similar what we were doing. We were analyzing these waveforms in real time. It was the equivalent of like 60,000 real-time conversations. Like that's the data that we were taking in
Oh,
at that
wow.
point in
Okay.
time. But we weren't listening to conversations. We were listening to, well, conversations between physical matter and the photomultiplier tubes that were looking at the inside of this detector. But nevertheless, we had to build the compute infrastructure for it. We had to build the air conditioning, because you're deep underground, it's super hot. You have to figure
Yeah.
out how to exhaust that heat. You have to build a detector, you have to simulate it, you have to build FPGAs in order to analyze the data, and then you have to store the data and analyze it and all this stuff. And so it was just a 15-person team building this like supercomputer deep underground, and then analyzing, cutting edge data to try to figure out the fundamental laws of the universe. And so that's the background that I came from. And we thought it was so cool what we got to do, that I was like, man, it's such a shame that there isn't like a documentary or something being done about this or whatever, right? Actually,
Yeah.
now you can actually go out and find them. There are documentaries about it, but just at the time there weren't. And so what we did is built little devices to record audio all day, every day, to basically life log, to make a backup copy of what we were doing,
Okay.
just because we thought it was so cool. And that's what got us into audio. That's what got us thinking about, like, hang on a second, the technology that we're developing here can be applied to actually search inside audio waveforms and find interesting moments inside, and you can do it in aggregate across a really large body. And so then it has applicability in call centers, it has applicability in podcasts and all sorts of things. And that's what got us thinking, hey, um, is anybody working on this? And we actually
Yeah.
went out and talked to Google and Microsoft and others, and literally set up meetings with their speech teams. And we got laughed out of the room when we met with them, independently. They said, well, speech is too complicated. End-to-end deep learning is never going to work for that. And we're just like, I can't believe what these people are saying. They have no idea what's about to hit them. And that was us, like, giving ourselves the internal go-ahead to say, like, we're going to start this company because these people don't know what they're talking about. And now Deepgram is the largest speech to text API in the world, and we're expanding our product line to just include all of audio AI.
Oh, wow. Wow. That's fascinating. Yeah, I was kind of digging into your background, separate from the company, and I saw that you had done all this work at University of Michigan. And my first thought, because you said you were, 2 miles under the ground, and I thought, well, is that under the big house or was it under Zingerman's? Was it somewhere in Ann Arbor? But no, it was over in China. But yeah, no, it's interesting how you then connected the dots, not necessarily to think about, starting a company, but going like, look, we're here doing this project. There's a bunch of other interesting aspects to it that we'd like to capture, and that led you to where you are today. So, very, very cool background story. I want to start by sort of looking at it a little bigger picture before we dive into the technology and the company and so forth. A lot of us have dealt with audio and voice technologies, Siris and Alexas, and we're seeing new things come, out of some of the the big LLM types of things. From a maturity perspective, you've been dealing with this now for a little while, and obviously, like you said, some of the biggest people, companies in the world said this is really hard to do. Where do you see, sort of whether it's NLP or audio related AI, any of those categories? Where do you see them right now in terms of maturity and where we are in terms of sort of interacting between human voice and computing systems?
Yeah, there's a point at which a technology like catches, and
Yeah.
then it's like real. And when it's like a real viable technology, it like turns on and never turns off again. So for instance, like the automobile, like electricity, like the
Right.
internet, like etc. And prior to those, there were always sort of like murmurings, and you can kind of see the like that something is about to happen, but
Hmm.
anybody in the market is not necessarily sure it's happening yet,
Yeah. Yeah.
um, that that state of like, oh, is it going to happen? Is it real this time or whatever has been going on in voice for like the last 20 years, essentially.
Right.
But I can like definitively say it's here. It is turning on. It's real. And there's a few different areas to talk about there. So there's quality and there's latency,
Hmm.
and then there's just like cognitive ability, essentially. And there are a lot of low-hanging fruit, use cases out there that you can do with not a ton of cognitive ability, but even with that the case, you still have to have really good perception, which is essentially knowing what was said. So
Right.
not necessarily knowing what it means or how to respond, but knowing what was said. So that's like speech to text, or topic detection or that kind of thing. And then you need to have really good generation so that when you're speaking back, you actually speak like a human and can, interact with a person. And so that would be text to speech or TTS.
Right.
Um, and if you just go back 2 years, like TTS sounded like a robot. Nobody wanted to interact with it. And then to fold in the latency piece here, it was also too slow.
Right.
So if you were to call and try to interact with one of those systems, it would sound horrible and it would take too long and it would probably not know what you really want to hear.
Right.
All of those things are pretty solved now.
Okay.
And
Good.
and I don't mean like in all installed systems out there in the world. I mean at the technology level and at the product level. And now there's a dissemination that has to happen, of this like first version of the new wave of voice AI technology. So the maturity level is, especially on the perception side, the maturity level is very high. This is because there were voice AI use cases in the past 10 years that didn't need interaction. So, for instance, if you're trying to index all videos on YouTube or all podcasts or whatever, like this is what we do for Spotify, we index all of their podcasts to make them searchable. That type of technology has been around now. Deepgram has been around for 9 years, and we released our product like 7 years ago. So that type of technology has been around now for 7 years. But the human like really low latency TTS generation has only been around for like a year essentially.
Okay.
And the cognitive abilities of like an LLM have only been around for maybe 2 years, a year and a half, et cetera. But they're all getting put together now, with low latency to make it actually feel like a real human experience. Now there's a new 2.0 version of voice AI that will come out after this first one gets disseminated across the world. And that one will have deep context passing between all of these different models. But we could talk more about that if you wanna hear
Yeah.
about
No,
it.
no, no. It's fantastic, and that's what I was kind of trying to figure out is obviously a lot of the things around AI and a lot of interesting voice technology has been around for quite a while. I was involved with sort of the earliest like voice over IP days and stuff, which was 20
Hmm.
years ago or something.
Yeah.
But yeah, I was really kind of curious because it feels like so much has changed just in the last 2 years or even the last year. like how much, how much of that sort of acceleration takes place. And it sounds like, what we've all sort of been experiencing now is the technology's there, and like you said, the dissemination sort of has to follow, but the expectation is that the dissemination will follow fairly quickly, I would guess.
Yeah, there's one thing I didn't mention, which is like the quality, the modalities, the latency. I talked about all of those, but the cost really matters too.
Sure.
And the reason for that is you're competing with um uh, like the a good baseline way to think about it is you're competing with folks across the world that have different cost of living
Hmm.
that maybe are making like $2 to $5 an hour in their call center job in the Philippines or somewhere like that. And
Right.
so you can't have like $2 per hour speech to text, $5 per hour text to speech, and like $5 per hour LLMs, and then add a RAG cost on top of it and whatever. It's like you're paying $20 an hour in order to do this task. It doesn't make sense. You could just hire a human, right?
Right. Right.
So you have to keep the price level like less than $2 an hour basically for everything. And all of that is coming together right now too. So you can have a massive scalable deployment.
Yeah, no, that makes a ton of sense, and it does feel like it's the one aspect that doesn't always get talked about when when we people get fascinated by kind of the headlines and what's possible. And so in that vein, sort of thinking about it from a business perspective, I'm curious. You guys obviously, like you mentioned, widely deployed. What is sort of the business thinking? What's the business mindset when you start saying, okay, for example, I run a call center. Maybe it's based out of wherever, and it's doing fine, right? It's serving the purpose of the business, and you start saying, okay, we want to start introducing voice aided technologies into the business. Like, what's the typical process? Is it sort of, does it start with cost? Does it start with what's kind of what's the brand image that we're trying to portray? What's the quality of the service? Like, what's sort of the thought process, and which ones tend to be higher priority than maybe other aspects of the decision?
Yeah, the typical thought process right now, and this will change in a few years as people start to see, like they start to be able to imagine, or not just imagine, but they've already seen examples of all of this being deployed. But right now, it's in a different phase where there are many different sectors out there that just haven't been touched with voice AI yet, and so they have to like dream up how it's going to work for them. And the way that they go through that process is typically uh, you start out with the most expensive. You don't care that much about latency. You start with the most expensive, most expressive models, and then
Hmm.
you build a demo
Okay.
essentially.
Yep.
And that demo, then you try to steer in a way that you're talking about, like getting the voice right or getting the talkative level of it to the right level, that kind of thing. But once you get the quality right, the alignment of that agent, and then the latency low enough. So typically like responses below 800 milliseconds or something like that, a little less than a second. Um, that's when everybody's eyes light up and they say, "Whoa, this is going to be real." But think about the assumptions that went into that. They went with the most expensive. They
Hmm.
weren't necessarily thinking about where it's going to live or anything like that. And that's when they actually start thinking about the more practical matters that you're just mentioning, like cost or speed or whose data goes where, and that type of thing.
Right.
So they have to kind of get themselves excited via a demo mode first, and that will get leaders excited, and that will get kudos to the engineers that built it and all of that, and then that gives everybody a good feeling, saying, "Hey, this is worth going after. At the very least, I know it's not going to fail. It just might cost too much." Okay.
Right. Right.
And then they go down this path of like, can we build it and make it successful and make it not cost too much? And then that takes typically, it's actually shorter than most people would think. It's not like a year or something like that. It's maybe 3 months or something like that, and then they can get to a deployed POC with maybe one, two, or three of their biggest, or like essentially most beta friendly type customers, but some big beta friendly type customers, and they ship it to them. And with some intent focus on getting that right, then it's just like 3 months later, and they're saying, okay, I know exactly how all this is going to work now, and I need this part to run on premise. I don't need this other part to run on premise. I need these models to be adapted. I don't need these other models to be adapted. That type of thing. They start to figure all of that out. And then they put some points on the board and start getting some wins around certain uh, like categories of interaction. So one thing I always suggest is don't try to boil the ocean. Don't try to do everything. Don't say, hey, we're trying to replace everything that a human could possibly ever do. That is a bad
Yep.
idea.
Yep.
What you should be thinking about is like, what is the low hanging fruit? Are people calling in and trying to like reset their password, or are they trying to uh, like just search for an item? Are they trying to just like figure out the hours of a store? Are they whatever? Like these are all things that can be handled by a machine very easily. So set the bar there, but then go handle those interactions. And for many like call centers or things like that, that's like the majority of their interactions. And once they can start to see success there, then they start to see success. They start to be able to imagine the success in the other areas. And but at that point, though, I start to warn people and say, hey, pump the brakes, make sure that this other stuff is rock solid and you're getting the benefit from it. And then you start to uh, write down and formulate a plan for the more complicated matters, because you may need more cognition, you may need more adapted models, you may need to spend more, et cetera. But yeah.
Yeah. No, I mean, and a ton of that makes so much sense. I mean, part of it, you could replace voice AI with any technology, right? Like find low hanging fruits, go through, do proper POCs. But it does seem like there are certain really important points in that description where, voice is obviously one of those things, like you said, that it's a human interaction, right? Like all of us, whether you're a manager or the CEO or, technician or whatever, like you sort of know what a human interaction seems like, what voice seems like. And so it's probably the thing that people are most critical about in terms of being like, I don't, I'm not totally sure this is right. But you also highlight, right? It's really important to kind of figure out, how do I make sure that this aspect of it is trained really well, right? Like you're looking at quality and all those sort of things that you might not in a, quote unquote sort of minimum viable type of scenario.
Hmm.
But I would guess that process of kind of going through it and validating it both from a technology perspective, but also sort of a human perspective, then becomes something, like you said, once you kind of get that right, you can pretty easily take it to other groups or other scenarios and be like, look, this is the learning curve that you guys can skip, because we've been through that with the
Yep.
things and so forth. So yeah, that makes a ton of sense. That's kind of like you said, the sort of most expensive systems are the ones that are looked at first, because again, you don't want to provide sort of bad quality, bad experience, robotic stuff, whatever it might be,
Hmm.
up front, because it's really easy then for people to go, no, no, it's not
Hmm.
there. Let's not do that, and
Hmm.
so forth. So it
Hmm.
makes a ton of sense. Let's dive a little bit into how you guys go about delivering this. If I was, let's say I'm an application owner listening to this, like what's the process to go about saying, like, I have an existing call center, or I want to bring kind of voice centric AI to
Hmm.
some application I have. Like, what's the typical process? Is it like you mentioned it's an API, but like what's
Yep.
what are the scenarios tend to be?
Yeah, we're a B2B API that has a bunch of SDKs. We have communities to help get people started. We have tutorials, we have blog posts that can,
Hmm.
we have example code, open source example code that can get you going, et cetera. So those are all really good places to start. But there are lots of ways to do that wrong,
Sure.
incorrectly too.
Yeah.
And we tried to put a lot of effort into making it really easy to get started. Just going to the web page, like initially just going to the web page, and you're not just confronted with a bunch of documentation. You have to figure out like how to make it all work, because audio is kind of complicated to get working,
Yeah.
especially in real time. But you can go through a path of like, no, here's all pre-built stuff that you can just use, and you can get a feel for the latency, you can get a feel for the accuracy, and that kind of thing. Then hey, the code is right there. You can dissect it. You can change it, in the ways that you need. And then once you understand that as an engineer, you'll probably say, okay, I'm going to throw all of that away and I'm going to build my own. But now you just shortened that learning curve. You just steepen that learning curve.
Right.
So so yeah, we focus a lot of time on that, because we actually have a PLG plus plus standard like sales motion at Deepgram. So we have account executives, we have folks that are reaching out and talking with buyers, and their technical people are talking to our applied engineers that are helping them get it going. But then there's also, you can just go to the website, sign up, buy credit basically, and just use it however you want. But
Yep.
that means that you have to have a good education base in order to get it working. But so one thing though to think about how we actually make it all work behind the scenes is we uh, so we're actually a research company that productizes as fast as possible. So we push the frontier on what is possible with models. We don't open source them, but we're a closed source company. But many of the things that like the new technologies that folks have seen come out with, for instance, like Whisper from OpenAI, which is a speech recognition open
Yep.
source speech recognition engine that OpenAI released. This is what we were doing like 7 years ago at Deepgram, but they're open sourcing now.
Yeah.
Um, but nevertheless, like that, we are pushing the frontier there, but then we're bringing it to production as fast as possible to keep the cost of goods sold really, really low, and then
Right.
the reliability of the underlying system really high. Because hey, this is when you're using Deepgram in real time, it's hundreds of milliseconds matter, and so it's an underlying just like strategic piece of infrastructure that our customers rely on. And in order to make that all real, we have a hybrid approach where we have our own data centers and we also use the cloud. And we train our models in our own data centers, but we serve our inference in our own data centers and in the cloud, depending on the use case for the user. So what that all means is you could run Deepgram on totally on-prem air-gapped if you want. You could run Deepgram on-prem with an internet connection if you want, in your own four walls. You could run it in your own private virtual cloud. You could also, we could just host it totally for you. We can adapt a model for you. We can host it for you, etc. And so I like to look at it as, what would I, as a developer early on, before we ever started Deepgram, when we were out looking for tools like this, what would I want?
Yeah.
What
Yeah.
what would I want? I would want the optionality. I would want to know that it's super reliable. I would want to know that it is the fastest model, and that the accuracy is the best. And I want all these things on these like 7 dimensions. And don't get me wrong, it took me a long time to build all of those. We've been a company for 9 years now.
Sure. Sure.
But now we're like in that position for speech to text, and so that's what people can expect when they get started with Deepgram. A fast deployment, and then just really good product.
Yeah. Well, and you and I were sort of briefly talking about this before we recorded, about the needs of businesses, and not everything makes sense in the public cloud. I know there's a lot of concerns by people who, are worried about, where does my data go? How does my data kind of get influenced in a model? Does the model stave stuff? And when you're talking about voice conversations, the challenge obviously is, you're right. You could be doing nothing more than just serving out, what time is the store open?
Hmm.
What's the time of day, or whatever it might be. But you might also be recording, important executive internal conversations that are being used and transcribed. You could be talking about sales conversations with things. There's a lot of stuff that is very, very highly sensitive, that people may not, want outside of their four walls, may not want outside. So it's very cool that you guys are giving people the flexibility, because I think the reality is, that's just a necessity of business, right? It's a necessity, and especially voice conversations, because they can be, maybe outside of like financial data or customer data, like some of the most important and sensitive data that you're going to have within the company.
Yeah, it's a great point. This is why when I describe Deepgram, I say we are a B2B audio AI company.
Yeah.
But
Yeah.
the B2B is first. And what you're
Yeah.
talking about, that what businesses actually need, that's where we're coming from. And it's actually really tempting when new AI technology comes out to sort of think flashy and think consumery.
Right.
Um,
Right.
and I, that's great. I think that's really good for educating the market about what is possible, essentially. But creating an actual real product, you need to have like the ability to adapt a model, but have it only be used by that one customer,
Right.
rather than
Right.
it's like, okay, if we're allowed to train on your data, then now everybody gets to use it, and it's
Exactly.
like, whoa, for a
Exactly.
business, like for most businesses, they can't do that, right?
Right.
So you
Exactly.
need to build a product that works in that way. And I think a lot of AI companies now, or at least what people are familiar with as AI companies right now, they're actually mostly consumer focused,
Right.
and they're
Right.
not really thinking about building in the what businesses need. But yeah, the what you actually need as a business is the ability to choose like the price to latency trade off, the ability to choose like price to accuracy trade off, the ability to run it hybrid, fully on prem or fully hosted. et cetera. And yeah, that's not, as we can see, like that's not the case with OpenAI or others, et cetera.
Right.
That's fine. It's just it's early in the market. But the companies that are truly building for B2B, they are building for that.
Yeah, absolutely, absolutely. Real quick for folks that are kind of new to this space, what are some of the most common use cases, and then maybe what are one or two kind of cutting edge things that you're starting to see people even explore or ask you if it's possible?
Yeah. So I think about the trajectory of voice AI in sort of three phases. There was the just listening phase,
Hmm.
which it never ends because it's always there, but like it was the only thing up until maybe 3 years ago, like basically right around the time that, or 4 years ago now, I guess, right around the time the pandemic started.
Yeah.
So that would be like you have a bunch of podcasts and you would like to make them searchable, or
Yep.
hey, I run a call center and there's 10,000 agents and I can't listen to everything that they're saying every day, but our customers talking about other competitors, like are agents trained well, that kind of thing. So it's like an analytics type approach, but that is all done through batch mode. So it's
Hmm.
after the recordings are already done. There's no like turnaround time, big problem or anything. You just need them indexed so that you can figure out the different trends and make them searchable and that kind of thing later.
Yep.
Um, but around the time of the pandemic, and actually it's kind of funny, we saw this in the data, we saw this in the customers coming to Deepgram. The real-time revolution and that VoIP revolution that we saw in COVID and all that, it actually started probably about 6 months or maybe a year before
Hmm.
COVID. So it was
Okay.
already kind of getting kicked off. We saw it in our business. But then COVID happened and then it like really ramped up essentially. So this is
Yeah.
the time of like real-time agent assist. So like you have a call center and you have AI listening in to uh, to help with a knowledge base and show on an agent screen like, hey, it sounds like this person is having a problem with X or Y, and this essentially shortens the time to training call center agents and that kind of thing. There, this also was the time where folks started to kick off like voice ordering for food and that kind of thing.
Sure.
So
Sure.
and that's when it got started, but actually that didn't really get perfected until like the last like year or two. I wouldn't even necessarily perfected, but it got into a workable state basically in the
Yeah.
last
Yeah.
year or two.
Yeah.
But now we're in this stage that's kind of the final boss, which is real-time agents that sound human-like. And I would say it's still just starting, but it's like just
Hmm.
starting in a big way very rapidly. And yeah, that those other states like the just listening state and then the like adding in real time conversation and then the full real time agent, like all of these are blending together now. And depending on your use case, you'll use different components of it, but you actually put essentially all of them together in order to make the agent work. And yeah, I expect the voice AI agent rollout to happen over like the next 2 years, like, but there will be like a 1.0 version, which is
Hmm.
the one that's not super contextualized and it won't have as much cognitive ability, but it'll still sound like a human mostly.
Yep.
And that'll be like everybody cutting their teeth on how to use, voice AI agents. But then they'll start to demand, once they get to a certain level, like, hey, in these cases it fails. 80% of the time it works well, but 20% of the time it doesn't. Let's cut into that 20% of the time. Well, when you want to solve those, you're going to need context. You're going to need context across all the previous conversations you've had with that person. You're going
Yep.
to need like context around like are they mad or not? What problem are they trying to solve? And all of the things that make us feel like you responded with you're right, but it was just like a monotone, like you're right.
Yeah.
And if the you're right that you responded with was supposed to be sarcastic, or if it was supposed to sound doubtful, or if it was supposed to sound whatever, like these are all the things that really make a conversation feel like a human is when you add
Yeah.
all the emotion and emphasis in there. Well, you need context throughout the entire conversation that is passed along between all of these different models in order to do that. And so that's kind of giving it all a personality, but giving it a contextual understanding as well. And that is actually it's a really hard problem because right now you would just take speech to text and it would take audio and it would convert it into text. And then that text would get injected into a large language model, which will then generate more text. And then that will get injected into a text to speech model, which generates speech, and that completes the circuit, and everything is done, right? But
Right.
if you actually look at the underlying things that were passed along there, it was only text and it was only literally what was spoken. there's so much more information in an audio stream about how they sound,
Yeah.
and throughout that conversation. And that's the problem when you only stitch those together. So don't get me wrong, that stitching together, that voice agent AI like 1.0 is still going to do a whole bunch of work. Okay.
Yep.
But then
Yep.
the next version that everybody's going to demand is one where it's actually contextual. And that'll be like the 2.0 version, probably in like a year and a half or 2 years is when sees massive rollout.
Yeah. Yeah. Very, very cool. Let me ask you one last question, and we'll let you get out of here. We'll maybe it, for people that are thinking about deploying this, or people that have deployed it, like how do they get feedback of what the user interaction is, right? Like there's lots of stuff in like retail to look at, carts and how long people stay on page. Like, how do you go about doing that in a voice context when obviously, you could, like, yeah, basically, like, how do you test this stuff and know whether people enjoyed it, hated it, like how does that sort of stuff work?
Yeah. So there's some basic ways that you do it with that are very like human, hands-on, kind of expensive ways. And that's
Yeah.
what everybody starts with, and that's a really good way to start. Where you have like human groups that you go out and source, like user testing groups and whatnot, and you like
Yeah.
record them while they're using it, and all sorts of things, and you figure out like what's working and what's not working. Um, but that's the first pass, and it gets you some good preference and whatnot. But you need that also at scale.
Yeah. Sure.
And I'll be frank in saying like that is not built at scale yet.
Okay.
So we're still in the first innings of that. So think about like the first inklings of the cloud and AWS and all of that, right? When things were first being launched, there wasn't there weren't there weren't great services for like centralized logging and inspection and that kind of thing, right? You
Yeah.
just kind of
Yeah.
set it up and you just used it and you hand rolled your own and that kind of thing. But then a few years into it, Splunk and others, and like then things started to come around, right?
Yep. Yep.
And so I like to think of this as like the world is a fractal. You solve one problem and then that's all good now. Okay, well then you just restart the cycle in another area for those problems. So think about how audio here was started out. Like I painted the picture of audio starting out as just observing basically over time
Yep.
and
Yep.
getting the batch mode observability of audio going all right. Well, now you're going to have like the batch mode observability of voice AI agents, and then you'll want the real time version of that, and then
Yep.
it's like
Yep.
it all just rinses and repeats. But
Gotcha.
yeah,
Gotcha. No, that's
yeah,
helpful. That's it. And again, it's, kind of going back to the original question of, where are we maturity wise? It's good to know, not only maturity of the technology, but maturity of then the life cycle and user interaction, all those sort of things. So,
yeah.
well,
Anybody who
Scott,
wants to start a company out there, right? That's a good one. Observability of like AI agents, right, and the
sure.
underlying systems. But yeah,
There you go.
anyway,
Good
yep.
stuff. Well, Scott, thank you so much for all this. Obviously, like you said, you and the Deepgram team have been working on this for quite a while. Lots of easy ways to get started. We'll, put links to the things in the show note. But thank you so much for this. Like I said at the beginning, we love to sort of dive into new areas of technology. It's cool that you guys have been not only doing this for a couple of years, sort of, tip of the spear, but you've been doing this for a long time. You're really kind of creating what the leading edge is. So it's been fascinating to dive into this and learn a little bit from it from you. So thank you so much for that. Thank you to the Deepgram team for allowing you to have some time with us today. So, folks, with that, on behalf of Aaron and I, we want to thank Scott for his time. We want to thank you all for listening. Thanks for telling a friend and helping us grow the show and grow the community around this. And with that, we'll wrap it up. We'll talk to you next week.
Thank you.